Exercise 8, perpendicular distance formula, part 2. Number 1. A 3, 4, B 5, 8, and C 7, 6 are the vertices of the triangle ABC. We have to find the length of AC, find the perpendicular distance from B to AC, and hence determine the area of the triangle ABC. I pause the video. There's one little thing, when you're plotting points, just make sure the scale on the X and the Y is the same. This makes it a bit easier to check your answers. Okay, right, here we go. We're going to plot these points just, fairly accurately. So 3, 4. Let's have a look. We're going from 3 up to 7. So that's 1, 2, 3, 4, 5, 6, 7. And we're going up as high as 8, aren't we? 1, 2, 3, 4, 5, 6, 7, 8. And we have 3, 4. It's about there for A. Okay, we have 5, 8. 5 up to 8 there for B. And 7, 6. 7, 6 up to about there for C. So we have to work out the area of that triangle. But first of all, we work out these parts. Now, the length of AC, using the distance formula, which is simply going to be the square root of 7 minus 3 all squared, plus 6 minus 4 all squared. Okay, and that comes out to square root of 20, which is 2 root 5. Right. Now we're going to find the perpendicular distance from B to AC. From B to AC. Now clearly we need to find the equation of AC. Right. Now to do that, we can say that the gradient of AC, that's part 1. Part 2. The gradient of AC is the difference of the y values. It's 6 take away 4 over 7 take away 3, which is a half. So y minus 4 equals, using the point gradient form, minus 3. And that, on rearranging, and comes out to x minus 2y plus 5 is equal to 0. Okay, so that is the equation of that line. And we want to find the perpendicular distance from B to AC. So using our little formula, we know that x1 is equal to 5. And we know that y1 equals 8. Okay, 5 and 8. Okay, so now we know that A is equal to 1, B equals negative 2, and C equals 5. So P is equal to, now that's just 1 times 5 is 5, and minus 16 plus 5 all over square root of 1 squared, which is 1, plus minus 2 squared, which is 4, and that comes out to, it's going to be 6 over root 5. Okay, or if you like, 6 root 515. And we found that on the perpendicular distance from B to AC. Now the area of the triangle ABC, the area is going to be a half of this base that we worked out earlier, which remember was 2 root 5. 2 root 5 times this height, which is 6 root 5 on 5. And of course, these go out, and root 5 by root 5 is 5, so those will cancel out, and you get just 6 square units as your area. Okay, number 2, we have to find the distance between the two parallel lines. 2x plus 3y minus 1 equals 0, and 2x plus 3y plus 2 equals 0. Now, to do that, pause the video. Okay, now here we go. So what we've got is we've got two parallel lines. So what I want to do, I'm going to look at this particular line here, this one. So we'll let that be the 2x plus 3y plus 2 equals 0. And I'm going to find a point on it. So I'm going to let y equal 0. So when y equals 0, we find that 2x plus 2 equals 0, so x equals -1. So we have a point on this line which is 0, -1. Now, to find the distance, we mean the perpendicular distance, therefore I just work at the perpendicular distance from this point to this line. Alright, the parallel. Okay, here we go. So my x1 equals -1, my y1 equals 0, my a equals 2, my b equals 3, and my c equals -1. So p equals, now it'll be -2 plus 0 minus 1 all over the square root of 2 squared, which is 4, and 3 squared is 9, and that becomes simply 3 over root 13. Or if you rationalize that, you get 3 root 13 over 13. It's probably not necessary really to rationalize units.